Okay, so in this problem, let's do letter C. For the reaction for A plus 3B, then it forms 2C. The following data were obtained at constant temperature. Okay, so we have this data, the table here. Then we are asked what is the order with respect to each reactant and write the rate law. So we have answered those two questions. And let's go to letter C. Calculate K using the data from an experiment 1. Okay. From the answers we've solved in letter A and letter B, we have arrived the rate, which is rate is equal to the constant times the concentration of A, which is second order, and the concentration of B, which is first order. We have the concentration of B, which is first order. So we have this rate. Okay. Now let's solve, okay, using that rate law. Let's solve K. Right, let's go. So we have rate is equal to K times concentration A squared times B. Okay, so let's solve K's. So in solving K, we just divide both sides. A squared over B. Okay, A times the concentration of B. So cancel, then we are left with a formula which is K is equal to rate over A concentration and B. So now let's plug in the value. So we will use this formula. K is equal to rate over A squared over B, B concentration B. Now let's have a K in rate in experiment 1. Okay, let's use the data here. In experiment 1, we have the rate which is 5 mole per liter minute. 5.0 mole per liter minute, and over that is over to A. The A is point 100, and then we have B, which is point 102. Point 100 mole per liter times this is square, point 100 mole per liter. So we have K. That is 5.0 mole per liter minute over point 100 squared, that is 0.01 times point 100, that is 1 times 10 to the negative 3. Okay, mole square per liter square, because when we square, we also square the unit. So we have mole square per liter square here times mole per liter. Okay, when we times the same number, we just add the exponent. So here we have the same unit, mole per liter, and then squared times mole per liter. So we will have mole cube per liter cube. Okay. And then this one, we have mole per liter here, so we will cancel that one. Okay. All right. No, we will not cancel it yet, sir. We will not cancel it yet. I will show you. Hmm, I can't. Okay. All right. Now let's do that one. So we have here 5.0 mole per mole per liter minute. Okay. This one here is equal to here and then in the numerator. Okay. So in order for us to to bring this denominator into the numerator, we will, oh, not necessarily that we are going to bring it to the numerator, but when we divide a fraction, so we can have multiplication but reciprocating it. Okay, so let's multiply. I use this so we will really see what will happen to the units. Okay. Yes. Cube. Okay. So here, now you see that one? Liter divide. Okay. This one, we can cancel that one. And then mole. We can cancel mole here. 2 na lang ni siya diri. Okay, so we will be left with 5.0 divided by 1 times 10 to the negative 3. That is 5,000. 5,000. Okay, so what's the unit? We have liter square. Okay, liter square over mole square. Okay, no, over mole square minute. Okay, you see this one? Okay, so that's our answer, or we can write that one to a scientific notation. 5.0 times 10 to the 3. Okay, it's positive. Liter square per mole square minute. Okay, so if you write it in a scientific notation, then you are correct. Or if not, 5,000 is the rate. The value of K is rate constant is 5,000 liters square per mole square minute.